Hi there! The solution of an equation is usually a number or a set of numbers. The solution of a differential equation is a function. To check whether a function is the solution of a differential equation, you just plug it into the equation and check whether both sides balance. For instance, for the differential equation y prime equals cosine of x, the function y is the sine of x is a solution. Namely, the derivative of sine x equals cosine of x. In fact, you can see that for this easy equation, each solution is of the form yx equals sine of x plus c, where c is a constant that can be chosen arbitrarily. This set of all solutions is called the general solution. The equation y prime equals 2y is slightly more difficult, since it contains both y and y prime. Do you immediately see a function y is fx that satisfies this equation? In class, the first answer that often comes up is y is x squared. Do you see that this is not a solution? Well, if you substitute this function into the differential equation, it leads to the equation 2x equals 2x squared, which is certainly false, isn't it? As a function, 2 times x is not the same as 2 times x squared. Well then, if y is x squared doesn't do the job, which function does? The exponential function comes in handy here. The derivative of e to the power 2x equals 2 times e to the power 2x. So this is indeed a function for which the derivative equals twice the function itself. Do you see how you can vary this function to find other solutions? In this case, adding a constant c doesn't work. The derivative of e to the 2x plus 5 equals 2 times e to the 2x. And this is not equal to 2 times e to the 2x plus 5. No, for this equation, multiples of the solution e to the power 2x provide more solutions. The derivative of c times e to the 2x equals 2 times c times e to the 2x. In fact, all solutions are of this form. So the general solution is y equals c times e to the 2x for an arbitrary c. In this case, it is not immediately clear that these are indeed all solutions, so I'm afraid you have to believe me on my brown eyes when I tell you that they are. This way of guessing a solution won't always work. Moreover, there isn't a solution method that works for every differential equation, like there is an ABC formula that works for any quadratic equation. You may think this is a pity, but I would rather say that this makes the search for solutions interesting.